Hello, welcome back. In this lecture, we will get to know a little about Ethereum clients and their purposes. Let's remember that to be a blockchain node, it is necessary to run client software. In the case of Ethereum, you need to run two clients, an execution client and a consensus client. This occurs since the change of consensus mechanism from proof of work to proof of stake. Such clients have different purposes. The execution client manages and executes blockchain transactions and implements the Ethereum virtual machine. Before the move to proof of stake, the execution client was also responsible for consensus. This is no longer the case. Currently, the execution client does not create new blocks, but expects new blocks to be provided by the consensus client. The consensus client manages the ledger. It receives and propagates blocks to, and from, peers, and updates the execution client with new blocks. The consensus client is only responsible for maintaining the chain of blocks and not the state of the blockchain, which is the responsibility of the execution client. Anyone wanting to keep the ledger up to date must run a consensus client. The consensus client, by itself, does not propose or attest to new blocks. For this, it is necessary to run a validation client, linked to the consensus client. We will not detail how the consensus client works in this course. Examples of consensus clients are Go Ethereum, also known as Geth, written in Go. Nethermind, written in C#. And Hyperledger Besu, written in Java. For greater network security, there is expected to be diversity in the use of clients. That is, that no client becomes dominant in the network. Unfortunately, this is currently not the case. According to current data from the clientdiversity.org website, Go Ethereum is currently used by 64% of the network nodes. As it was one of the first clients to be created, this is expected, but it is expected that other clients will gradually become more used. Examples of consensus clients are Prism, Lighthouse, and Teku. There is a greater balance between implementations in this area, with Prism and Lighthouse being the most used clients. As consensus clients are newer than execution clients, it is natural that there is no predominance of only one implementation. One question that may have arisen is the advantages and disadvantages of being a node. Currently, there is no need to be a node to participate in most blockchains, as several nodes receive requests from participants, free of charge, and propagate these requests to their peers. Let's start by discussing the advantages of being a node. One advantage is privacy and availability. It is possible to create a transaction from its own node, without requiring to submit it through another node, which may or may not propagate it further. As long as your node is connected to the internet, it will always be available. Being a node also helps with network security, which is proportional to the number of participants. If the network has only a few nodes, this can put it in danger. The blockchain is secure as long as the majority of its participants act according to the rules of the game, so the greater the number of nodes, the more difficult it becomes for a malicious participant to cause damage to the network. The biggest downside to being a node is its cost. Since nodes need to keep the ledger of the network up to date, and the ledger is a record that only grows, the disk space required to store all the blockchain information is not small. Currently, for most clients, being an Ethereum node requires around 1 terabyte of disk space, not to mention the computational power and the internet bandwidth needed. One of the concerns of Ethereum and other blockchains is the high cost of being a node, which can lead to a decrease in the number of participants and consequently lead to a reduction in network security. There is not just one type of node, but different types. The most common one is called a full node. In it, the participant maintains the entire ledger and the current state of the blockchain, but does not necessarily participate in producing new blocks. Miners are those full nodes that actively participate in creating new blocks. If the consensus mechanism is proof of stake, they may be called validators or proposers. Archive nodes store the entire history of the state of a blockchain. For example, it is possible to consult the balance of an account at a given moment in time. Archive nodes must store terabytes of data, so they are often only offered as a service. Light nodes do not store the entire ledger, but usually just the block headers. They take up little disk space but must fetch data across full nodes when needed. In this course, when we refer to nodes, we will generally be referring to full nodes.